Alright, section 1.4, the last section of chapter 1, is on page 45, talks about the tangent and velocity problems. So the tangent line and velocities, those are kind of go hand in hand. We'll connect those together. Let's start with a tangent line. A tangent line is a line that touches the curve at one point. The point extends a line that is perpendicular to the center of the circle. So, if I wanted to really kind of get an idea of how those look, I would think of a circle, and the circle is touching at one point right there. I would think of a circle, and a circle is touching at one point right there, only at that one point. I would think of a circle, and the circle is touching at one point. A circle here, and maybe a circle here. And this is what you're trying to see. You're trying to imagine a line that's gonna run that touches this at one point, but this line is perpendicular to the radius. Let me use a different color. So you're trying to imagine a line like that. It doesn't have to be perfect. Here, if you want to imagine a line perpendicular to the radius, here, if you want to imagine a line perpendicular touching through that point, same deal here, and same deal here. Now, of course, we don't want you to graph a circle and the line. We just want the line and kind of you figuring out the slope is positive, negative, which is bigger, which is smaller, something like that. So, let me start by defining. We know what a secant line is. Tangent line, you take it in geometry, probably forgotten. What a secant line is. A secant line is a line that intersects a curve in at least 2 points. So here's one, and here's the other. It's a straight line that crosses at 2 points. And if you call these points, if you call this point x1, y1, and this point x2, y2, then the slope is the average y2 minus y1 over x2 minus x1. Right? Now, when I start with what we need in this chapter, we need to find an equation of a line. Actually, I need the slope of the line more than anything. Actually, here it is. I need the slope of a line. Well, we have a problem. And what that is, this line that we want to find an equation of is tangent. So if I pick a point right there, I will notice that the line, okay, you know what? Let me go ahead and make that right here. I would like to find an equation of that line. At this point, this is y equal f of x. If I call this a, this is the point a, f of a. And we're really going to take a out of the way and replace it by h. So this would be h, f of h. They're going to use a later on. And the way the idea that works, well, I don't know how to find an equation of a line through one point, right? Unless it passes through the origin. This one doesn't. Then I say it's rise over 1. What I do, I pick another point. So I start by saying, okay, entertain my idea, and let's pick a point right there. And let's say I'm going to stick with the f of a part. Oh, sorry. Wrong key. I'm going to stick with the f of a part. So if I pick a point right there, and this point, and I draw a secant line. If I draw a secant line and say, look, I'm going to take this and I'm going to call this point a plus h. What that means, I moved h units away. What's h is? A very small number. And I'm going to say, look, the slope of the green line, the slope of the secant is y2. Now, if this is a plus h, do you agree that this is a plus h, f of a plus h? I'm going to say the slope of the secant is y2 minus y1 over x2 minus x1. And if you notice what we're getting the difference quotient. And you're going to say, but wait a minute, something's not right. You're going to say that doesn't make sense at all. That is, the green line is nowhere close to what we want. Say, okay, well, can we cut this h in half? Whatever h we picked, let's take half of it. Right? H over 2. What would happen? If I take h over 2 and draw a secant line, hey, then it's the red. And you're going to say, wait a minute, but the red is not that purple. It's still far. I say, okay, but do you agree that the red is better than the green? Meaning, the approximation, the slope of the red is what I could find and use it to approximate the purple. It's not exact, but it's closer. What if I took this and I cut it in half again? Do we agree that this new line is closer to the purple than what I want it? And do you see what's going to happen every time I get closer and closer to this H, to this A? My line is going to get closer and closer to the purple. So, if I look at this slope of the line, if I was to replace A by X, right? And this is X plus H, that will be X plus H and f of X plus H, and say the slope of the secant is y2 minus y1 all over x2 minus x1. That is f of x plus h minus f of x all over h. And you're going to say, wait, but something's still missing. It's still not equal. We say, yeah, well, look, what happened when I started with h? I started with the green line. Then when I took half of h, I got the red line. When I took half of that, I got the blue line. So do we agree that as h disappears, if I take the slope of the secant line, which is f of a plus h minus f of a all over h, and if I apply the limit and let h approach 0, that would be the slope of the tangent line that I want. Right? Or I could use any other letter. I could use x as well. It doesn't really matter. And guess what? The slope of the tangent is the definition of velocity. That is instantaneous rate of change, the rate of change at that one specific point. So what they're going to do in this chapter, they're assuming you haven't seen a limit yet, so they're going to try to really enforce that, and that turns out to be a lot more challenging if you didn't know about limit. That's why we did the sections backwards. So look at this problem. It says the point lies on this graph. A, if Q is a point on this function, is the point on this x, cosine of pi x, use your calculator to find the slope of the secant approximated 6 decimal places. And notice what they're doing. I'd like you to think about this just for a sec. They're starting at 0. Then they're going to 0.4. So they're starting at 0. Then they're going to 0.4. Then 0.49. then 0.499. Then they're going to 1 to 0.6. Oh yeah, 0.4 would have been a lot further the way I drew it. 0.4 would be about right there. Then they're going to 0.49. Then they're going to 0.499. And they're going from 1 to 0.6 to 0.51. And do you see what that's called? That's called a limit. They're taking the limit as x approaches a half. Literally. How are we going to do this? The same way we did what we worked on before. We're going to work it out the same way. The fixed point here is 1/2 0. So if I take the point I, for example, I'm going to say the slope of the secant is, I'm going between 0, 0, and 0.50. So if I take y2 minus y1 over x2 minus x1, I'm sorry, I rushed. If x equals 0, then y equals the cosine of 0, which is 1. And I'm going to run to 0.50. y2 minus y1, 0 minus 1 over x2 minus x1. And I'll plug this in my calculator and see what I get. And I'll get here a -2. When I go for the second piece, so this is I. When I go to double I, I'm going from 0.4, the cosine of pi times 0.4, right? And I'm going to run from that to 0.50, and the slope of the secant here is going to equal y2 minus y1 x2 minus x1. And do you notice what's going to change? Those are fixed, right? And if I run from for 3, if I run from 0.49 and the cosine of pi times 0.49 to 0.50, right? Wouldn't the slope of the secant be y2 minus y1 0 minus the cosine of pi times 0.49 divided by 0.5 minus 0.49. Now, how come I'm not plugging this in my calculator? Because I want to show you how we're going to do this repeatedly. We know how to do that. What we're going to do, the only value that's changing, we're going to take parentheses 0 minus, and it seems to be the cosine of parentheses, what? Pi times answer. Right? That's the top divided by 0.5 minus answer. Now, all what I have to do is go in there and plug in the 0 to check if this works. So if I plug for a 0, a 0.5, and a 0.49, that should give me the answer automatically. I should get a 2. Let's see if that works. So if I take a 0, enter, now it's starting my answer, go back up and hit, there it is, -2. If I take a 0.4, enter, and if I go up and evaluate, I'm going to copy that number. They want us to get it to 6 decimal places. So what they want the y's to really combine to 6 decimal places. And if I run and do this again, and I'm going to do the right afterwards, if I take a 0.49, enter, and if I input that, there's the value. And if I use my calculator on all of these values, that's what I will get.